Hey folks, welcome to Chapter 4, Section 3, Congruent Triangles. In this video we're going to basically identify congruent parts of triangles, and with that information we're going to conclude that these two triangles are in fact congruent. So at the top I have this sentence. In two congruent polygons, all the parts of one polygon are congruent to the corresponding parts or matching parts of the other polygon. These corresponding parts include corresponding sides and corresponding angles. So just think of corresponding parts as matching parts, the similar looking ones in appearance. They might even be marked. So like this pair of triangles here, everything's marked, but like angle J would correspond to angle B. Like this triangle's like upside down, and it looks like it's rotated a bit too, because like HJ's here, and then AB is there, and that's like the short leg of the triangle. But basically, what we're trying to say is, if you know that all the sides are congruent, then you know that all the angles are congruent. And if all those things are congruent, well then, yeah, definitely those two triangles are congruent to one another. And so you would conclude your statement by writing a congruent statement. And so like in this example here, it says triangle ABC is congruent to triangle HJK. So it doesn't matter the order that you use for the first three letters for the first triangle you mentioned, but whatever order you use when naming your triangle, it's gotta match the corresponding parts of the other triangle. So like, see how they said A, B, C? That goes like 2, 1, 3, right, with the dash marks. And so their congruency statement says HJK, so it says HJK 2, 1, 3. So it's the same pattern. So I could have said like triangle BAC, and that goes 1, 2, 3, and then I would have to say is congruent to triangle JHK. So just make sure you get the order correct when you're writing your congruency statement. See how this example of not a valid statement says ABC, that goes 2, 1, 3 is congruent to HKJ. That goes 2, 3, 1. See, so that's the wrong order. So everything needs to kind of like match up, so to speak. That being said, let's do our first example here. So I'm going to identify all the congruent angles, and then I'm going to identify all the congruent sides, and then I'll write my congruency statement. So my congruent angles, it should be pretty obvious. They're all marked. But yeah, you would say angle L is congruent to angle Q. Then you would say angle J is congruent to angle P. Then you would say angle K is congruent to angle M. And that's, just pointing out all your congruent angles. And so next I'll look at my sides. So I see that JK is going to be congruent to MP. And then LK is going to be congruent to MQ. And then JL is going to be congruent to PQ. And so what you say is, for your congruency statement, it doesn't really matter the order you choose to mention your first triangle, but you got to match it with the second one. So I'll say something like triangle. I'll go from like smallest angle to biggest. So I'll go like triangle L J K, right? Small, medium, large. So I'll say is congruent to triangle, and then I'll go small, medium, large with this one. So I'll go QPM. And so that'll be my congruency statement, okay? It's just concluding it with that. Moving on, I have this definition to read to you. The phrase if and only if in the congruent polygon definition means that both the conditional and its converse are true. So if two polygons are congruent, then their corresponding parts are congruent. So for triangles, we say corresponding parts of congruent triangles are congruent, or CPCTC. So it's just the reverse is true. So before we said, hey, all these parts are congruent, so therefore the triangles are congruent. Now going backwards, using the properties of CPCTC, says, hey, these two triangles are congruent, so therefore all the other corresponding parts must be congruent. So using that, let's figure out our missing variables here. So here I have 8y minus 5 for angle F. And so angle F is going to correspond with angle B. So I'm going to do 8y minus 5 equals 99. And I'll definitely want to solve for y first here, because looking at the variable with the x, or the expression with the x, it says 2y plus x. So I need to figure out y first in order to figure out x. So moving back to this, I'll add 5 to the other side, and I'll get 104. And so I get 8y equals 104. And then I'll divide both sides by 8. And so that's going to give me a value of 13. So y equals 13. Okay, so if y equals 13, then I just got to plug it in right here. And then what is it going to equal? Well, FE looks like it corresponds with BC, so that means I'm going to set it equal to 38.4. So I'm going to say 2y plus x equals 38.4. And then I know what y is. I know y is 13, so 2 times 13 plus x equals 38.4. And 2 times 13 is going to be 26. Plus x equals 38.4. And so I'll minus 26 over to the other side. And looks like that's going to give me, was that 12.4? Yeah, x equals 12.4. And so there we go. That's example 2. In example 3, says in the figure, triangle ABC is congruent to triangle FDE. Find the values of x, y, and angles D and F. So let's see what we got here. The first thing to figure out, or the easiest thing to figure out for me, is looking at angle y corresponds with 48 degrees. So I just say that y equals 48. And so angle y is tucked in with angle D, so therefore angle D equals 48 degrees. Next, I'll move on to angle F. So angle F is 2x minus y, and that's going to correspond with angle A. But we don't know the measure of angle A yet. But you know that all the angles in a triangle add up to 180 degrees. And so if you minus out the two that you know, 108 and 48, you're going to get, I think, what is that, 24? Yeah, that's 24 degrees. So basically, we just figured out that 24 degrees goes here, and because it corresponds with angle F, it also goes there. So that's going to be the measure of angle F. Now let's just figure out what x is. So we're going to say 2x minus y, except we know that y is 48. So 2x minus 48 equals 24. So we're going to add 48 to the other side, and that's going to give us 72. So if 2x equals 72, divide both sides by 2, right? And 72 divided by 2 will give me a value of 36. And so that's example 3. Alright, so before I wrap up these notes, we are going to do a proof. And before we do the proof, I'm going to point out this definition, or this theorem, I should say, and that's called the third angles theorem. And it basically says that if two of the angles are marked as congruent, then you can conclude that that third unmarked angle is also congruent to one another, the corresponding angles. And then because we're doing proofs, these properties of equality often come up, and so you may be using the reflexive property, which says the same thing, like A equals A. Your symmetric property, which just says the same thing in reverse order, like A equals B, so B equals A kind of thing. And then your transitive property, if A equals B and B equals C, then A equals C. So one, two, or all three of those may come up, but probably just one. So example 4, write a 2-column proof. Given that DE is congruent to GE, DF is congruent to GF, angle D is congruent to angle G, angle DFE is congruent to angle GFE, prove that triangle DEF is congruent to triangle GEF. So it's easier to understand if you just look at this picture. We basically, what we want is we want to conclude that all the sides are equal to each other, and then all the angles are equal to each other. So 2 of the sides are marked as congruent, 2 of the angles are marked as congruent. So I need to prove that that third unmarked side is congruent and that third unmarked angle is congruent. So I have some of it filled in for you. So the first statement says DE is congruent to GE, DF is congruent to GF. If you look, that's a given statement. If you look at the picture, those are the 2 marked sides. So your first reason is that that is given. And so if you know that 2 of the sides are congruent, it's time to prove that that third unmarked side is congruent. So let's look at it. That third unmarked side is going to be EF. And if you look, EF is shared by both triangles. So the next thing you would write is that EF is congruent to EF, which, sounds very obvious, which, it is, but you got to mention it because it's part of both triangles. So that is, so if you're saying something's equal to itself, that's the reflexive property of equality. So I'm going to write this, reflexive property of triangle congruence in that statement box. Sorry, reason box. I said statement box. But yeah, so what we just did was we proved that all 3 sides are congruent. So let's talk about the angles now. So if you look at the given statement, 2 of the angle pairs are given to you. And so that is what comes next in the statement box. Those 2 marked angles. So because they were already marked and it was also in the given statement, you can just say that your reason for that is it's given. So moving on, we know that 2 of the angles are congruent. So basically I just need to prove that this third unmarked angle is congruent. So you probably already saw it, but I am going to talk about the third angles theorem, which says that, hey, if 2 of the 3 angles are marked as congruent, then you can conclude that that third angle is congruent. So we just need to properly identify that third angle. So it looks like the third angle is going to be, let's see here, you can call it FED or DEF. It doesn't matter as long as E is in the middle. So I'll just say, I'll go alphabetical. I'll say DEF is congruent to FEG. And so once again, we know that because of our third angles theorem. So what we've done now is we proved all the sides are congruent. Now we've proved all 3 angles are congruent. So now we know that our 2 triangles are congruent, and we know that because of CPCTC, or that corresponding parts of congruent triangles are congruent, so therefore your triangles are congruent. So what you're trying to prove is always going to be your last statement. So you're going to write triangle DEF is congruent to triangle GEF. And so now that I got that there, I'm done with this proof, and that's going to draw these notes to a close. So thank you for watching, and goodbye.